Hey everybody. So today we're going to take a little break from working on the 10EE. As you know, we're getting started, ready to get started on the cross slide and the compound, and then lastly will be the taper attachment. So my plans right now, get the cross slide on there so I could get the oil hole plugged up with the hand wheel. And then we'll put some power to this thing, put the tubes in, I'll show you that as well, and then we'll get it powered up, we'll see how it works, and then we'll finish off the rebuild, and then this will be done. So I've been getting a lot of questions about my plans for these 3 10EEs that I have. So as you know, I rebuilt one already about maybe 2 years ago. Same color, basically the same machine, a little bit newer than this one, maybe 4 or 5 years newer. So I am going to be selling 2 of the 3 that I have. I'm going to be keeping 1. So I have a couple people that have already reached out, and I've had some dialogues with them. Timing wise, I'm not really sure, probably this summer. I want to finish this one. My intent right now is to keep this one. I will probably sell the other one that I restored. That one does not have an electric lead screw. And then the 30-inch, I'll probably move along to a new owner as well. At one point I was thinking about maybe doing a rebuild on that one and then selling it, cleaned up, repainted, anything that needed to be fixed that I'd fix. But honestly, I really don't have the time. So I've got so many other projects, work has been really busy, and it just probably would be a more intriguing project for someone else who's inclined to either just clean it up a little bit, put it to work, or maybe they want to do a rebuild on it themselves. So I'll keep you posted on what my plans, or how those plans sort of evolve, but that's where I'm at right now. I'm going to keep one and sell 2 of the others. So today's video, like I said, is a departure from working on the 10EE. I'm going to show you a video of my business, which is a sheet metal and machine shop. We're going to do a really quick walkthrough. It's not the greatest quality video. I had the image stabilizer turned off on the camera, so it's a little shaky. It's loud, but we'll do a walkthrough there. I'll show you what we have going on, and then I have a little sort of a cleanup project, like an emergency project. One of our customers needed a part of a large order shipped out right away. So we were pretty backed up in our manual machining area, so I brought it to my home shop here, and I did those second operations here. Don't really have to do that often, but every now and then stuff like that shows up. But it made for a little bit of an interesting video. Not a very complex thing to do. So let me move over to the video on the sheet metal shop. We'll do that walkthrough, and then I'll show you those parts that I worked on. All right, guys, so here's the shop. This is a big frame that we built for a customer with some sheet metal panels on it. So just kind of give you an idea. This is where things get started. Pack out some old packing material and so forth. But in this area right here is where all the raw stock comes in for the frame build. So this is all mostly square tubing and larger heavy stock. We have a tiger stop on that saw right there. We cut to length, get everything prepped up. There's some stock right there for projects. So you see we do some pretty large scale stuff. So let's move on. This over here is QC area?
This is all shipping.
Shipping, yeah.
We can take a walk into the QC room. That's
I'm trying to figure out how to hit the stabilizer button.
Oh.
I don't know. All right, whatever. QC room. You're on candid camera, boys.
Behave yourself. No dirty language. This is all press brake.
So guys, here's a couple press brakes that we have. I'm going to walk over to the welding area.
I'm gonna take a look at that. That's a big frame, huh? Vector frame? Yep. Yeah.
Charlie, can we watch you bend something, or you're not ready?
Tell you what, let me grab something here.
Okay. Don't bend it wrong on my account.
Oh, I did that already today. I took my practice. I don't do that often.
Finished part, huh, Charlie? And is that accurate to 1/10,000th?
It's probably
It is now. So this is the machining area. So we've got a couple Haas CNC machining centers. So we do a lot of aluminum brackets, some stainless steel stuff. We also have some manual milling machines just to do some sort of secondary operations and stuff. Alright, so this is a time saver machine. It's basically a finishing machine, deburring, cleanup. So you see here some stainless parts coming off that have a grain finish in certain directions for the drawing. It's a new machine for us. We had an older one. It just finally quit. We replaced it with this new one. It's a wet system as opposed to dry finishing. So you see we run a lot of parts through there. So this machine right here is a Bisotronics 4400 watt laser. It's a loading table right there, so it picks up sheets, puts it on that platen there, and rolls it into the machine. So coming up here in a few minutes, we'll show you cutting some material on this thing. Unfortunately, the doors have to stay closed, so you have to look through that kind of crappy plexiglass covers. But it's pretty cool anyway. That one's got a curled edge. Did you see that?
Yeah, luckily that's it won't
Get cut off.
Yeah.
What you're going to see the machine do at first is it's going to locate two corners. The one to the left there, you see he's kind of just doing a rough alignment. And the machine will come in, it'll find those two edges, and then it'll go to the other end of the sheet, and that will tell the machine the orientation, because that you can put the sheet in crooked and still cut straight parts. So there you see it's finding its Z, and now it's coming over and it's kind of walking to the edge to figure out where the edge of that sheet is. So you see it's creeping up on it, and as soon as it gets to the edge, it's going to go look now at the other axis, and once it finds this edge, it knows where that corner is, and then it's going to go to the other end of the sheet and figure out where that corner is. So repeat that process. Once it does that, then it'll figure out where to start cutting the parts. See that flash every time it hits the supports underneath. This material is aluminum. I believe it's an 1/8 inch thick, 125. And you'll see it, the material kind of curling and moving around, as it's relieving the stress, heating up a little bit. You have to be very careful that the head doesn't crash into those parts, so the operator knows when he's nesting parts which way they're going to curl, and make sure the head's out of the way. It does occasionally crash, and that's a $400 accident. So fortunately it doesn't happen very often, but that little lens at the end is what gets damaged. You also saw there it cut a few holes, so rather than punching holes or drilling holes, it just cuts little holes. Those are probably like 1032 cleaned holes. So this here is an Amada punch press, so it's got a big setup on top with a bunch of tools. I just walked into an area that just shut it off, so I got to walk around to the other side. Sometimes that head will come out, or that chassis will come out and extend past the machine, so I just, there's like a laser curtain there. It knew I was there, so it stopped. Started back up when I got out of the way. So we'll come back around to this side, and you'll see this machine basically punching a bunch of holes and features into this flat stop. So on the right hand side, you see the little grippers. It's holding the sheet, and it's sliding on these like little whiskers that support the weight of the material to hold it in place. And then there's a platen below it right where the punch works. So we'll watch this for a little bit. It's fascinating to watch this thing run.
Together a little marketing video. You never know. Oh, right, that's right, exactly.
So this machine, we use it in conjunction with the laser. It's a lot faster than the laser, but it's not as flexible, and it requires tooling for the different operations. But we've worked out which machine is more efficient at what operations. So we'll just keep watching this for a little bit. It's going to change to a different pattern, and you'll notice the sound will change. Sounds like Led Zeppelin. Nice. We're back over at the laser. Just show you a few more things. These are like somewhat bigger parts. You see there again, cutting holes, making all these different little bracket assemblies. Pretty cool.
Thing wants to focus on the plastic instead of the laser. Doing some pemming. How does that sound?
That's the downside of having blue eyes.
Oh my god, it's bad. Light sensitivity, killer.
Yeah.
But coming into your job, go home. Can't really.
So I got this project to do. I got these 6 pieces of sheet metal that we made in the shop that they get punched on a punch press, laser cut, holes are laser cut. These holes are punched. And because of the way the bend radius is, if you look at right over here, so the bend radius for this slot, we punch this out and then we form the corner, but we can't punch out that close because you wind up getting cracking in the, this is aluminum, you wind up getting cracking. So what we did was we punched out the slot, formed the side, so then I've got to stick it in the Bridgeport and then just shave 110 thousandths off of that. So what I did was I get it clamped up in here. It's sheet metal, so it's not to 10 thousandths. I just get it trued up with the table so that when I spin it down this way, I can get that hole pretty cleared up. So there was also another issue with these guys. I didn't get these on film, but so these plates right here, same issue here is we can't get into this corner with only 3/4 from the bottom. So the drawing calls for 3/4 from this face to this face. So it winds up coming up about, this one was 0.938. So I shaved all 6 of these down, fixtured up in the milling machine, and then just ran along and just cut off what I needed to cut off to bring that down to 3/4. So I will show you the drawing right here. I just got to cover up who's from. So you can see where that dimension is at 0.75 2 times, and then you see the 900 mil to size after forming. So we take 150 off. Yeah, so it was 900. And then this one that I'm doing that I just showed you on the milling machine, again, I gotta just be careful of, can't let you see the customer here. Let's see, okay. So there you can see this right here. So the note, which is just handwritten, so the slot needs to be 0.31, so we have to mill 110 off after forming. So my shop is super busy, so I took it to my home shop here, and we're going to be milling these guys up for them, doing it tonight. So I'll bring it back when I turn this thing on. All right, it's probably going to be a little noisy. So I got a 4-flute carbide because that's the only end mill that I have that's reasonably sharp enough that I can get it into that slot. Actually, I'm going to shut this off so that I'll get it down and okay. So now I'm just going to get in between the little parts that are formed from the punch. Just want to touch off. So I'm just barely touching, and you can hear it hit where the punch overlap, the tooling overlap from the punch. So I'll come over here to the end. I'm going to zero out my Y. slide it back a little bit. And we'll get this part off of the mill. We'll go back to the finishing department. They're gonna get DA'd, and then they're gonna be sent off to some kind of a plating and then powder coating. Okay, so I'm just gonna do that 5 more times. Okay, there's all 5 done. Why don't we grab a caliper and see if we're reasonably close to the 31 that we need. So right at 31. Well, that's pretty good. Where are you at? A little bit thin in the middle. Oh, you know what? There's a burr on it. Yeah, okay. So I'll clean the burrs up. You can see all the burrs on. I'll have to clean those off. But this one side right there, there's no burrs. It was due spec.